Hello, welcome to everyone in this video. Today we want to discuss about the solution of question paper CC5 in the physics honors under University of Calcutta 2022. At the very first you try to solve this question. This is the question paper. This is question number 1 A, B, C, D, E, F, G. Then question number 2 A, B, C. Then question number 3 A, B, C, D. Question number 4 A, B, C. Question number 5 A, B. Then question number 6 A, B, C, D. Then question number 7 A, B. So I request all of you at first you try to solve this question. After that continue the video to watch the solution. Okay. So I think clear about the mission. So let's start. First question, explain what is the physical meaning of the constant term in Fourier series expansion. Actually this is the Fourier series expansion, you know, that is a0, aon, bn are the constant, and these are the significance of the average value of the parameter, right? Next question, using generating function of Legendre polynomial, prove this relation. This is the Legendre polynomial. If we put x equal to -1 in both sides, you will be find out this relation x equal to -1. So this is plus and this is 1 plus t whole square. Function of this experiment, and if you compare the coefficient of t to the power n, you will be find out this relation. Next question says, discuss about the singularities of the following equation. So in the first question, p of x, that is the general form of this differential equation, is like that: d2y dx square plus p of x dy dx plus q of x to y equals to 0. So if you comparing with this general equation, you can see p of x is 0 here and q of x is -6 by x square. So at x equals to 0, this q of x is diverged. So if you multiplied x minus x0, that is 0 q of x at x equals to 0, you will be get that is finite. So this x equal to 0 is regular singular point. Okay, this is diverged, so this is singular point. This divergence can be omitted here, finite, so this is regular singular point. But in that case you can see this is not omitted, this is again diverged, so this is irregular singular point. If you attend my theoretical class, you just correlated this example. In an alpha particle counting experiment, the number of alpha particles recorded in each minute for 2 hours. The total number of particles is 500. How many 1 minute interval do we expect no particle? So the number of minutes here, 2 hours mean 120 minutes. So average rate is total 500 by 120, that is 25 by 6. The probability 0 particle in a minute is using Poisson distribution, you will be get this one. So the expected number of 1 minute interval with no particle, 0 particle, that is no particle, n0 equals to t into this. So 1.86. Obtain the Percival identity for Fourier series. So this is a theoretical portion we already discussed in theoretical class, that is the Percival theorem, or the completed with the useful ways relating the Fourier coefficient is like that. Next, so that the gamma z plus 1 is z gamma z, this is also discussed in theoretical class. That is the definition of gamma function. If you put n plus 1 and then integrating by parts, you will be obtain this relation. Here use n, actually I taken from this theoretical class, but here you just put z. So you just put z instead of a, so n converted into z. Okay. Next question, so that this beta relation, that is p beta pq equal to beta qp, this also discussed in theoretical class, that is so where we use mn. So just taking this and put this x equals to 1 minus z and interchange, you will be obtain this relation. Okay, so here also change this m by p and n by q. Okay, so just notation is different. In theoretical class we discussed this. Find the Fourier transform g of k of the function is like that. Plot this. So given function is like that, and Fourier transform of this is the formula, and putting the value of f of x here and taking this the sum is like that. E means exponential, so taking in the form of square form, after that you will be gives this relation. and this gives you the gamma function. Finally you obtain this is okay. This is the gamma function formula. So you can see the given function and the transform function both are the Gaussian, and this is the question already asked in the previous year in the year where says that the Fourier transform of Gaussian distribution also a Gaussian distribution. Okay, so this is proved here also, and their distribution nature will be like that. Next question, what is the physical meaning of sigma? Find out the corresponding quantity g of k and show how many they are related. Okay. What is the physical meaning of this? Sigma satisfy the standard deviation, signify the standard deviation. Find the corresponding quantity g of k and show how they related. So in case of g of k, this is a, so if you just find out the k square and summation k, this gives you 1 by c. Next, when sigma tends to 0, it will happen for f of x and g of k. For f of x, this gives you 0 by 0, that is constant, and this gives you 0. Next, evaluate this question, evaluate this integration using beta and gamma function. This is the beta function formula. Given integration, if you comparing these two integration, you can see that is 1 plus x whole to the m plus n. So this is 1 here, and this root x can be written as x to the minus half, that is m minus 1 is minus half. So m is half and n is half. To know this relation between beta and gamma function, that is beta mn equals to gamma m gamma n by gamma m plus n. So if you just put this relation, that is gamma half plus half. Gamma is root pi and gamma 1 is 1. So this integral value will be pi. Next, show that beta n comma n equals to beta n comma half by 2 to the power 2n minus 1. We know that basic formula of beta function, that is beta nm equals to 2 0 to pi by 2 sine to the power 2n minus 1 theta cos to the power 2m minus 1 theta, and this the gamma m gamma n by gamma m plus n. If we put m equals to half in both sides, that is beta n half, that is 2 0 to pi by 2 sine 2 n minus 1 theta, and cos here if you put m equals to half, this is cos 0 and cos 0 is 1. So this term will be 1 here. Okay, and in this right hand side, that is m equals to half, that is gamma half gamma n, and this again put m equals to n, that is b n comma n, that is gamma n gamma n plus n. So this is gamma n whole square by gamma 2n, and this in this form, integrand form, that is put this m n both are same, and if you taking just 2 here, if you just taking 2 here to form the sin 2 theta formula, sin 2 theta formula is like that, sin 2 theta equals to 2 sin theta cos theta. So you need here 2 to the power 2n minus 1. So just that's why we divided by 2 to the power 2n minus 1, and this is gives you sin to the power 2n minus 1 2 theta by this. Now put this 2 theta as t, and substituting you will be obtain this one, and after that you will be get this is a beta function. This already given, you know, that is the for definite integral the variable can change as a whole, that is t change to theta, no problem. So this gives you this formula. So this is the proof of this relation. Okay, clear? Next, prove that gamma 2n equals to like that. In just previous we proved this relation, and you know this formula beta function to gamma function. So beta nn gives you gamma n by gamma n plus n, and in this form this is gamma n gamma half, and so gamma n one single one is cancel out, so gamma n by gamma 2n is like that. So gamma 2n equals to 2 to the power 2n by root pi, and like that. Okay, so this is clear. Next, prove that gamma half is root pi. This is also discussed in theoretical class, that is the gamma n is the basic formula of the gamma function is like that, and if you taking x to the power n equals to y. So, taking the derivative and change the variable, will be obtain this relation, and finally will be get the gamma h equals to root y. Clear? Go to the next one. Find the Fourier series of the periodic function f of x equal to e to the power x within this period. So, this is the formula of Fourier series expansion. A0 is like that, an, abn. So, a0 if you find, this is gives you 2 sine hyperbolic pi by pi, n gives you like that, is this one, and after that just taking the by parts, and you know this gives the same I value. So, this type of integration you already done, and bn gives you the this value. So, finally, the sum of these 3 expression a0, an, bn gives you the final Fourier expansion or Fourier series. Next, if f of x equals to f of minus x, that is even function, and g of x equal to minus g of x, that is odd function, which terms should be present in the Fourier expansion of f of x and g of x within the period? So, this is the Fourier expansion formula. When this is a even function, you can see here that is bn will be 0, because this is even function and sine function is odd function. Since f of x even function and sine of x is the odd function within this interval minus 1 to plus 1, minus a to plus a. So, the product also a odd function, and for a odd function this gives you the 0 value, this gives you the 0 value. For even for odd function, for if g of x is odd function, then what happen? This bn is 0, for that this bn is 0. Okay, bn is 0. And when what about the odd function case? For odd function, this a0 is 0, an is 0, but this odd gives you the not equals to 0. Odd gives you even function, odd even gives you odd function, and this is only odd function. So, finally, a0 is 0, an is 0 in case of the odd function, bn not equal to 0, but in case of even function bn 0, but a0 and an not equals to 0. Next, find the Fourier series expansion for f of x, that is cos square x. So, this is the f of x, and if you just taking the f of minus x, you will give the cos square x, that is the even function. For in case of even function, we just prove that bn equals to 0. So, bn is 0, only you need to find out a0 and an. So, a0 is gives you the value pi, and an, if you just integrating this one, gives you the 0. So, finally, f of x gives you pi by 2, because there is a 2 here. Next question, prove that the Legendre polynomial of different order are orthogonal. That is, if order are different, then they are orthogonal. Orthogonal means their product will be dot product will be 0. So, this is the Legendre polynomial. Since if you take pmx and pnx, pmx and pnx, 2 are the Legendre equation, then it satisfies this Legendre equation here. Now, if we multiplying pnx with this equation number 1 and pmx with this equation number 2, and then subtracting, you will be common this one and the subtraction, and this gives you common subtraction, and this gives you common here. Okay. After that, if you can see, you can see this is the derivative of this portion. This 2 term gives you this one, and this is the middle term. Taking the square and middle term will be like that. Okay, I think you can do this calculation. After that, just separate out, you will be get this one. Now, integrating with respect to x with this limit, you will be get, this is the derivative form. So, this is gives you the integration in the right hand written in left hand, and left hand written in right hand. And you can see this in the both limit, that is x equal to 1 and minus 1, this gives you 0, because this is 0 here. So, this gives you 0, that is when m not equals to n, this is the 0, that means these are the orthogonal to each other. Next, using the expression of Bessel's function, that is j on x equals to like that, so that these two relation. This is also we discuss in theoretical class, just captured. Jnx equals to like that, jnx equals to like 1, this is gamma function, this is factorial. If we differentiate both sides with respect to x, and then product with x, taking this plus form in the other two form. After that, actually this is we discussed in theoretical class and I copied from this portion. I think you if you attend this theoretical class you can understand this portion. So you will be get this relation, and after that again if we with respect to x and rearranging them from the another form, you will be obtain this relation. So these two relation will be obtained, and after that if you take their addition and subtraction, you will be obtain these two relation. Okay, so I think you can understand this already discussed in theoretical class. Next question: how does Fourier transform g of k transform extend where x equals to x plus a? So this is also discussed in theoretical. That is the shifting property in the Fourier transform of x, that is g of k, is like that. So if you Fourier transform f of x plus a, put the x plus a in place of, and this will gives you the formula. Next, g of k is Fourier transform f of x. Fourier transform f star is complex conjugate, so this gives you g star k. Next, so that in a certain limit binomial distribution can be converted into a Gaussian distribution. That limit is nothing, that is the a large number of trial. If large number of trial, this binomial distribution converted to the Gaussian or the normal distribution. Okay, so for that you need to use the Trelling approximation, that is n factorial is n to the power n e to the power minus n. So if you just using these steps, you can easily find out this. You can convert it the binomial distribution to normal Gaussian distribution. Okay, so you just follow these steps. Okay, this is the normal distribution or the Gaussian distribution. So this is the steps we need to follow. Okay, just put this expression n factorial for that Stirling expression you need to follow up. Then define this delta function and taking logarithm and use the log these two function. This is a neglected. These two function you will be obtain this relation. Okay, next, so that Fourier transform has property of Dirac delta function. Actually the Fourier transform of Dirac delta function gives you the 1, so the inverse of 1 is gives you Dirac delta function. This is the logic. You can just follow up the Fourier transform of Dirac delta function is 1, hence the inverse of Fourier transform of 1, that is the gives you the delta function. Next question: a bar 10 cm long insulated sided initially at 100 degrees centigrade, starting at t equals to 0, its end held at 0 degree. Find the temperature distribution of the bar at a time t. Use the heat flow equation. So this is the heat flow equation. Taking the separation of variable method, you will be obtain this solution. Now you will be use the boundary condition x equal to 0, u equal to 0, that is e0, because this cannot be 0. So u xt gives you, and x equal to 10 centimeter, u equals to also 0, so you will be obtain this relation, and this taking the summation because there is a linear combination solution. And if you use the another boundary condition, you will be obtain this constant fn like that. From this you will be obtain the constant fm. So this is the temperature distribution in the bar. Next, consider the vibration of circular membrane obeying this relation, partial differentiation, and this is the circular path cylindrical like that. So if you just separate it out, you will be obtain this temperature time part, and this is angular part, and this is the r part. Actually I did not continue this one. You try to solve this one. This is already discussed in theoretical class, the r variation, the cylindrical solution actually, right? So that's it for today. This is all about me. This is my contact details. So take care. Thank you.